All right, what about this one? Well, looking at this one, I think I want to solve for x here because that's going to be easy. All we have to do is subtract 2y. So x equals, now we have a negative 2y plus 7. Now I can plug this into the first equation for x, and I get a negative 2y plus 7 minus 2y equals a negative 7. So distributing the negative here, we get 2y minus 7 minus 2y equals a minus 7. Huh. So noticing that cancels that, negative 7 equals negative 7. That's true. So that means we have infinitely many solutions, infinite solutions, and we can say it's consistent and dependent. So we have infinite number of solutions. The system is consistent as well as dependent. Okay, so that was one of those easy ones, and we can't really check it. We could plug in and see what it is, but if we go ahead and look here at negative x minus 2y plus 7, if we go ahead and multiply that whole thing by a negative, then we get x plus 2y equals 7, x plus 2y equals 7, and so those are the same equation, just looking in a different format at the original equations. All right, what about this one? Looking at that, I see the y, so I'm going to solve for that. So I'll add 2x to both sides, and I get y equals 2x minus 3. I will then plug that into my first equation. So I get 6x plus 4 times 2x minus 3 equals 16. Now I get to distribute 6x plus 8x minus 12 equals 16. So I'll add 12. 6 plus 8 is going to give me 14x equals, and that's 28. Divide by 14, x equals 2. Okay. Now I plug the x equals 2 into any equation. I'm going to plug it into the second one because that looks easier. Minus 2 times 2 plus y equals negative 3. Well, 2 times 2 is 4 and it's negative, so we have to add 4 to both sides. And so that gives me y equals 1. And so I'm saying my equation should be, for the system, 2, 1 is my solution. Now let's check and see if it is. Okay, well, 6 times 2 plus 4 times 1 equals 16. That's 12 plus 4 equals 16. That's 16 equals 16, so it works in the first one. Now it should work in the second one because that's how we found it. Minus 2 times 2 plus 1 equals minus 3. That's a minus 4 plus 1 equals minus 3. Well, that adds up to a negative 3. And so it checks there as well. So it's independent and consistent. And that would be my solution to that one. Okay. All right, what about this one? Here we could do several things, but I think probably the easiest is to solve for x here. So what I'm going to do is I'm going to take x to this side and 14 to that side. So I'm going to add x, add x. I'm going to add 14. I'm going to add 14. So when I do that, to make sure we have everything canceled, that cancels that, x cancels that. And so we have here a minus 4y plus 14 equals x. And so then I can plug this into that point right there. And if we do that, we have a negative 6 times negative 4y plus 14 plus 8y equals 12. Now we get to distribute. So negative times negative is positive 24y. And now negative times that's negative, and we have 14 times 6, so that's 24, that's 84. And plus 8y equals 12. So add 84. Now like terms here, so that's going to give me what, 32. Y equals 96. Divide by 32. and y is equal to, looks like a 3. Okay. So if y is 3, let's plug that back into the first equation, minus x minus 4 times 3, and that's equal to minus 14. So minus x minus 12 equals minus 14. So add 12, negative x equals negative 2, or x equals 2. So now I'm saying my solution is 2, 3. So let's plug it in. Minus 2 minus 4 times 3 equals minus 14. That's a minus 2 minus 12 equals minus 14. Minus 14 equals minus 14. So it works, and it should, since that's how we ended up with our answer of x equals 2. So the real big check is going to be this one. Minus 6 times 2 plus 8 times 3 equals 12. Well, it's a minus 12 plus 24 equals 12. 24 minus 12 is 12. And it checks. And so it's independent and consistent. And so that would be our solution. Okay. And that's all I have. I hope that helps.